Good morning, friends. We are starting the module 5 nanotechnology, last chapter. Okay, previously we completed the instrumental methods of analysis. This is the last chapter under module 5 nanotechnology. Okay, in this session we will be discussing about the introduction, okay, and some of the properties of the nanomaterials we will discuss. Nanomaterials, okay, there is a lot of research is being going on this nano topic, because they are having a wider applications in almost of all the fields. Okay, nanomaterials is having a applications, particularly in medical fields. It's having a very much applications. Okay, so that it's a very concentrated topic to now present days. It's very important and fastly improving technology, that is nanotechnology. And in this we will have a discussion about the few properties of the nanomaterials. Okay, and we will be studying about few nanocomposite materials. So in this session we are starting with the nanomaterials chapter. Nanomaterials are the materials having the dimensions of around less than 100 nanometers in size. Okay, there will be generally 1 to 100 nanometers in a size. Nanomaterials is a substance in which the particles is in the range of 1 to 100 nm. Nanomaterial is a natural, incidental or manufactured material containing particles, okay, is an unbound or aggregate states. Okay, for example, when we take the size of the human hair, it's of the order of 1 lakh nanometers. Okay, nanomaterials is a 1 billionth of a meter, or 10 power minus m meters, minus 9 meters. 1 nm is approximately the length equivalent to 10 hydrogen or 5 silicon atoms aligned in a line. Okay, we can just imagine the sizes, how minute they are. Any material of nano size with its properties distinctly different from its bulk form is considered as a nanomaterial. Nanomaterials are building blocks of practical technology and can be physically and chemically manipulated for specific applications. Nanotechnology is the study of all the phenomena and processes involved in the synthesis, properties and applications of nanomaterials and nanostructures. Now, coming to the some of the properties of this nanomaterials, we are discussing few size dependent properties. Nanomaterials in terms of particle size are in between the bulk materials and atomic or molecular structures. They show you different physical, chemical and optical and electronic and magnetic properties compared to the bulk materials. Nano-dimensional materials exhibit different and newer properties than bulk materials because of their size. Okay, few size dependent properties are discussed here. When you take the bulk material, we are having a nanomaterial. Okay, that is a very smallest particles of 1 to 100 nanometers area. Okay, when we take the same substance in bulk, when we take, it will not be existing so many properties. But when you take a nanomaterial of the same substance, it will be having a wide range of applications and it will show peculiar properties. All the properties will be different. It will have a different chemical property, different optical property, different electronic and magnetic properties that we are discussing one by one here. When a bulk material is subdivided into individual nanomaterials, the total volume remains the same, but the collective surface area is greatly increased. Due to the increase in surface area, the properties like catalytic activity, gas adsorption, chemical reactivity, okay. For example, 1 cm cube solid mass is reduced to nano size. It gives rise to 10 power 29 can be nano cubes with a 1 nm cube dimension. Okay, each cube having 8 faces and 8 corners and having a surface area of 1 nm cube. Since all the corners are reactive, they can absorb a very large amount of molecules and can catalyze reactions. For example, bulk gold is catalytically inactive, but when we take the gold nano particles, they are catalytically very active, and for selective redox reactions they will be catalyzing. Okay, it is shown here in a diagrammatic way. See, when you take a bulk material, the area for reaction is less. Okay, when it is made into a smaller and smallest particle, see only this one cube here. Okay, all the corners are present for reaction. So all the corners are active here. So nanoparticle also, when they are separated, no, when they are separated, separate materials will be having a many properties compared to the bulk material. Okay, when the bulk material will be having structure something like this. Okay, all corners are not available for reaction here. When you keep on separating and when you take only few materials of the nanomaterials, as the surface area is increased, it will become highly active and it will be showing many properties. Okay, example is if you take a bulk gold, that is inactive, that cannot act as a catalyst. But if you take a gold nanoparticle, it will be acting as a catalyst. Okay, see, this is the way, gold nanoparticles. Okay, if we make different size of nano sizes of the gold, it will be showing different colors. This is used in a measurement of, outside the air will be there, in air pollutants measurement also it's used. Depending on different concentrations, it will be giving a different colors. At different concentrations of gold, it will be giving a different colored solutions also. Electrical properties. The electronic bands in bulk materials are continuous due to the overlapping of orbitals of billions of atoms. But in the nano size materials, very few atoms or molecules are present. So the electronic bands become separate. Okay, and the separate between the electronic state varies with the size of nanomaterial. Hence, some metals which are good conductors in a bulk become semiconductors and non-conductors as their size is decreased at nano level. Okay, coming to the electrical properties, friends. In a bulk, the material may be a very good conductor. Okay, but after it is made as a nanomaterial, when you study the properties of the nanomaterial, okay, it will be acting as a semiconductor, or sometimes it will be acting as a insulator. Okay, because the band gap will be like increased more here when you take only one material. See here, conductor, see the band gap, almost nil gap. Okay, so the electrons can jump easily. In the case of semiconductor is in between a very good conductor and an insulator. See the band gap in a insulator here. So when you take nanomaterials, nanoparticles, okay, their band gaps will become very more compared to the bulk substance. So they will be showing a or they will be acting as a semiconductors or insulators. The bulk will be acting as a very good conductor. When you keep on reducing the size to the nano sizes, when you observe the nanoparticle electrical property, as the band gap is very high, it will be acting as either a semiconductor or an insulator. Optical properties. The discrete electronic states of nanomaterials allow absorption and emission of light of a specific wavelength. Hence, nanomaterials exhibit unique colors which are different from bulk materials. When the nanomaterials are formed, they will be absorbing different amounts of light, as I showed the example of gold. Okay, depending on the size, it will be showing a different color because it is absorbing different amounts of different wavelengths of light at different sizes. That should be kept in mind. Okay, at different sizes, it will be absorbing different wavelength of lights. That's why it will be showing different colors. Okay, the nanoparticles of different size can scatter radiation of different wavelengths. Colors of few colloidal solutions are due to the scattering effect. Because of the scattering effect, it will be showing the different colors in colloidal solutions. When light hits the surface of the metal particles, electrons present on the surface starts oscillating back and forth and is a synchronized way in a small space, and the effect is called as a surface plasmaresonance effect. Resonating electrons have a cross-sectional area very much higher than the nanoparticles. Depending on the frequency of oscillation, resonating electrons can capture radiation of a different wavelength. See here, one more example. Bulk gold appears yellow in color, whereas the nano size gold appears red in color. The electrons are not free to move about in a bulk gold. The bulk gold, it's having a compact structure. Completely the structure is packed. Okay, what happens in the nanostructure? The particles are free here. It is because it is made to a nano size. The particles are compactly packed in a bulk gold. Electrons cannot move. Okay, in the case of nanomaterials, the property is restricted. The particles react differently with light. Okay, it will be absorbing a different wavelength of light so that it can show different colors depending on their sizes. Depending on their sizes, it will be showing different colors by absorbing different amount of the wavelengths. Thermal properties. Coming to the thermal properties, As the size decreases, surface energy increases and melting point decreases. This is due to the fact that the surface atoms require less energy to move because they are in contact with the fewer atoms of the surface, okay, substance. Certain nanomaterials have extraordinary thermal properties compared to their microscopic counterparts. For example, silicon nanowires have a much smaller thermal conductivities compared to the bulk silicon. Okay, silicon is a good in conductance. Okay, but if you take a nanomaterial of the silicon, it will not be a that much good conductor. Okay, and if you take a CDSE nanocrystal, it will be 2.3 mm CDSE nanocrystal melts at 700 K compared to the bulk crystal. The bulk, if you take the bulk crystal, it will be melting at 1678 K temperature. If you take the nanomaterial of the CDSE crystal, its melting point will be around 700 kelvins. Okay, so with this we are ending this properties of nanomaterials. We will be starting the new topic and meet again shortly. Thank you.